1. Exploring NASA's mineral mapping technology in Cuprite, Nevada. 2. NASA's Flying Labs, mapping Earth's hidden minerals from the sky. 3. NASA's Flying Labs, uncovering hidden minerals in the U.S. 1. Exploring NASA's mineral mapping technology in Cuprite, Nevada. Unveiling the secrets of the solar system, a journey with NASA's mineral mappers. Imagine a place on Earth that resembles the red planet itself, in the scorched hills of Cuprite, Nevada, where Joshua trees stand tall. We find a unique geological wonder. These hills, altered by deep underground water, offer a glimpse into Mars' ancient past. But it's not just about the scenery. Cuprite is a treasure trove of minerals, attracting prospectors for over a century. This makes it the perfect testing ground for NASA's advanced mapping technology, designed to explore our solar system's diverse landscapes. A historic partnership unveiled. The collaboration between NASA and the USGS, United States Geological Survey, has a rich history. It began during the Apollo era, where their joint efforts mapped the moon's surface, ensuring safe and scientifically rewarding landing sites for the Apollo missions. Even today, this partnership continues to thrive, with NASA's Artemis mission benefiting from the expertise of USGS geologists. The power of imaging spectroscopy. At the heart of this mission is a technology called imaging spectroscopy, pioneered by JPL, Jet Propulsion Laboratory, in the 1980s. This innovative tool, known as AVIRIS-Classic, is a spectrometer that can detect minerals and compounds on various celestial bodies, including Earth. It works by analyzing the unique light patterns reflected and absorbed by molecules, much like a fingerprint. In the case of GMX, Geology, Ecosystems, and Mineralogy Explorer, it captures the sunlight shimmering off different rock types, unveiling the invisible. Unlike a standard digital camera with its 3 color channels, red, green, and blue, AVIRIS-Classic sees over 200 channels, including infrared wavelengths invisible to the human eye. NASA's spectrometers have studied every major rocky body in our solar system, from Titan's methane lakes to Pluto's thin atmosphere. Now, they're headed to Jupiter's icy moon Europa to search for life-sustaining chemical ingredients. Looking back to move forward. Ben Phillips, a former NASA program manager, highlights the agency's unique approach. We develop technology to explore beyond our solar system, but we also turn around and use it to study our own planet. This dual perspective is a hallmark of NASA's innovative spirit. The evolution of AVIRIS. The GMX mission, scheduled through fall 2025, will see the retirement of AVIRIS-Classic after over 3 decades of service. Its successor, AVIRIS-5, will make its first flight in 2025. Together, these instruments offer 10 times the performance of the older spectrometer, with AVIRIS-5 capable of sampling areas ranging from 30 feet to less than a foot. A leap forward in mineral mapping. The GMX research project, funded by the USGS Earth Mapping Resources Initiative, will last 4 years. It will leverage NASA's spectroscopic imaging technology and expertise in analyzing datasets to extract critical mineral information. The data collected by GMX is available online, offering a wealth of information for scientists and enthusiasts alike. But here's where it gets controversial. What do you think about the potential of this technology? Could it revolutionize our understanding of the solar system and beyond? Share your thoughts in the comments below. We'd love to hear your insights and opinions on this exciting mission. 2. NASA's Flying Labs, mapping Earth's hidden minerals from the sky. Did you know that NASA's technology isn't just for exploring the cosmos? It's also helping us understand the land beneath our feet. A new mapping effort, called the Geological Earth Mapping Experiment, GMX, is using the same instruments that were once pointed at Mars, the Moon, and beyond to uncover critical minerals here on Earth. And this is the part most people miss. The search is happening right here in the American West, led by scientists from the U.S. Geological Survey and NASA's Jet Propulsion Laboratory (JPL). But here's where it gets controversial. The U.S. relies on imports for 50 different critical minerals, materials like lithium and rare earth elements that are used in smartphones, medical devices, and electric vehicle batteries. To reduce that dependency, the U.S. Geological Survey is trying to locate reliable domestic sources. And NASA's role is in the air. Flying at 60,000 feet, 18,200 meters, its aircraft carries sensors that can detect the molecular makeup of rocks on the ground. These sensors read light patterns far beyond what human eyes can see. Since 2023, the GEMX campaign has mapped over 190,000 square miles, 492,000 square kilometers, of terrain across North America. That's roughly the size of Spain. But what do you think? Is this a step in the right direction for reducing our reliance on imported materials, or is there a better way to achieve this goal? 3. NASA's Flying Labs, uncovering hidden minerals in the U.S. Imagine a world where cutting-edge space technology is turned inward to uncover hidden treasures right beneath our noses, critical minerals that are vital for modern life. NASA and the U.S. Geological Survey (USGS) have embarked on a groundbreaking mission to map these essential resources across the American West, using sensors originally designed for exploring distant planets. But here's where it gets really interesting. This isn't just about finding minerals. It's about securing the future of U.S. industries and national security by reducing reliance on imported materials. This ambitious project, known as the Geological Earth Mapping Experiment (GEMX), leverages NASA's expertise in space exploration to revolutionize Earth-based mineral mapping. By deploying advanced airborne sensors, scientists can now explore vast landscapes with a level of detail never before achieved. These sensors, which have already charted the surfaces of the Moon and Mars, are now scanning the Earth to identify minerals, like lithium and rare earth elements, that are crucial for everything from smartphones to electric vehicle batteries. The story begins in a place that could be mistaken for another planet, Cuprite, Nevada. For over a century, this arid desert has served as a testing ground for NASA's most sophisticated sensors. Robert Green, a senior research scientist at NASA's Jet Propulsion Laboratory, explains that Cuprite's mineral-rich hills, which to the naked eye appear as ordinary as the surrounding landscape, reveal intricate details when viewed through NASA's advanced sensors. This natural laboratory allows researchers to refine instruments that will eventually explore other planets, making Cuprite a vital link between Earth-based research and space exploration. At the heart of GEMX is the powerful technology of imaging spectroscopy, which NASA has been perfecting since the 1980s. This technique involves detecting the unique light signatures of minerals, essentially creating a fingerprint for each type. The Airborne Visible/Infrared Imaging Spectrometer, AVIRIS, is the core instrument used in this endeavor. The AVIRIS-Classic, which has been in use for over 3 decades, is now being complemented by its successor, the AVIRIS-5. This newer model boasts 10 times the resolution of its predecessor, capable of zooming in on areas as small as 1 foot across. This enhanced capability promises to provide even more precise data, aiding in the discovery of new mineral deposits across the American West. The collaboration between NASA and the USGS is deeply rooted in their shared history, stretching back to the Apollo missions. During those historic moon landings, USGS geologists worked closely with NASA to create detailed maps of the lunar surface, ensuring safe landing sites for astronauts. This partnership has evolved over the years, with both agencies now focusing on addressing Earth's resource challenges. Today, USGS scientists, led by geophysicist Todd Hofen, collect mineral samples on the ground, which are then compared with the data gathered from the air. This dual approach helps validate the accuracy of the airborne sensors, ensuring the reliability of the mineral maps produced by GMX. And this is the part most people miss. The potential implications of this project extend far beyond mineral mapping. By developing and refining technologies originally designed for space exploration, NASA and the USGS are paving the way for new innovations that could transform how we interact with our planet. As we stand on the brink of a new era in Earth science, the lessons learned from GMX could be crucial for managing our natural resources sustainably and securing the future of U.S. industries. What do you think? Is this a game changer for mineral exploration, or do you see potential drawbacks? Share your thoughts in the comments below.